Example 88.5. A recent study of the influence of diet and exercise on skeletal muscle and visceral adipose tissue in obese men found that men who used diet and resistance training for 16 weeks changed their waist circumference by an average of negative 4.69 inches. The standard deviation was 1.57 inches. The changes in waist circumferences were normally distributed. Find the change in waist circumference that corresponds to the 5th percentile. The change in waist circumference that corresponds to the smallest 5% change, in other words. Okay, so when I read the problem, a couple of things jump out at me. It's kind of a long paragraph, but I do see that they mention in the problem that the waist circumference changes were normally distributed. So I should draw probably a bell curve to solve the problem. All right, and if I'm drawing a bell curve, we know the standard thing is to label the z-axis at 0. The mean in the center, so the average here was negative 4.69 inches, negative 4.69 inches. The standard deviation here was 1.57. Okay, so remember this is a change in waist circumference. The fact that it's negative means that people lost size around their midsection. All right, from there, what we want to do next is to figure out, are they asking us for a probability, or is this a problem where we're using the table in reverse? Are we asked to find, say, a value that corresponds to a certain percentage or percentile? And when I read this, it says find the change in waist circumference. It doesn't say find the probability, does it? It says find the change in waist circumference. So we're looking for a value, and that means we're going to be using the table in reverse. So remember, anytime we do that, we have to think about where we should make a cut in our curve. So again, I'm going to draw these two little mini bell curves for us. And we're going to use these little mini bell curves to decide which one looks more like the situation we're dealing with. So should there be a cut on the left, or should there be a cut on the right? Well, what would be up here? This would be the top 5%, right? So let's think about this carefully, though. This is a tricky problem, and the reason why it's tricky is because of the fact that we have this negative here, a change in waist circumference. So be very cautious here. Let's think about something. You know, remember, ignore the z-axis for a moment and think about the x-axis only. On the left here, we get more and more negative, right? What does that actually mean if you're more and more negative? Doesn't that actually mean that you're losing more and more waist circumference? You're losing more and more kind of circumference around your midsection, right? So this would be good, right? This would be kind of the people who lost the most then, right? Because if this number gets smaller and smaller and smaller, like negative 10, that means you lost, 10 inches off your waist, right? So that would be a really nice change, of course, right? Well, that implies that these people actually lost the most. So it's kind of counterintuitive. We usually think of the people on the left-hand side as being the people who are kind of on the smaller end of things, right? Like they would be shorter or slower or whatever, right? But in reality here, the people down here actually lost more weight than the people up here. So if we actually want to find the change that corresponds to the smallest 5% change, the smallest change happens here, because remember, as you move up on the number line, wouldn't we be approaching 0? And what would a 0 change in waist circumference imply, right? If you're moving up on this X line, as you move close to 0, 0 would mean you didn't have any change, right? So these would be the people over here who lost the least amount around their waist from the diet and the exercise. So what I'm getting at here is that we actually are working with this side of the curve, not this one. This one doesn't fit because people down here in this particular scenario, which is unique, most problems this isn't true, but here, these are the people who actually lost the most. So we're looking for the upper 5% here, which really means what? The people who had the least change in waist circumference. So that's tricky, and there's no way around that. You have to really think carefully here, and you have to be very cautious sometimes and not just jump to the conclusion that you're working on the left-hand side. All right, now once you say that this is 5%, that means this must be 45%. How do I know that? Well, I know that because, of course, the whole half of the curve is 50. And that means that this must be 4,500. And the area from here to here is the one that matters most because I'm looking for the z-score that is associated with this area, right? Because this is how my table works. From the line to the center, it's that area that corresponds to this value. This area is irrelevant for us. It should be positive, the z-score, because it's on the right. So let's go ahead and do our table, look up 4,500, and find the closest z-score. We're going to see actually another important issue that arises when we try to look up this area. Let's go and do that now, though. All right, so we're trying to look up the value 0.4500 or 4,500. So remember, we look in this first column here, to look at the areas of probabilities until we find something close by. So let's move the table down because I don't see it in invisible screen here. So move the table down a little bit, and we can see that the closest area here is probably this row here. See the 44.5? So let's go over in this row and see something close, hopefully, to 4,500. So I look over, and I see two numbers here that look pretty similar, right? 4495, that's only 5 10,000ths away from our desired number. And then 4505, that's 5 10,000ths above our desired number. It looks like these numbers are both equally distanced from 4,500. So that's a dilemma. Whenever we have, not a closest value, so we can choose the closest one, we're going to have to take both numbers and average them. So if we look at this number, the 4495, that's 1.601234. So that's 1.64. And this one next to it then must be 1.65. So let's go back to our work and look at 1.64 and 1.65 as our z-scores, and we're going to kind of average them to get the number in the middle, and we'll use the average of those two z-scores for our z-score. So remember, we're returning with 1.64 and 1.65. Okay, so we went to look up our 4,500. We found that the z-score, it was between 1.64 and 1.65, right? It was right in the middle. We couldn't find a closer value because it was equal distance from both of these numbers. So what we have to do is pick the z-score that's right in the middle of these guys. So on a number line between 1.64 and 1.65, what's the number right in the middle? Well, you simply take the smaller number here, 1.64, and you just add a 5 to the end of it because that's halfway between 1.64 and 1.65. And that's what you will do if that ever happens to you on the table. Essentially, you're taking the average of the two numbers. If you add this number to this number and divide by 2, you will produce that z-score. So that is the appropriate z-score here because we did not have a closest value. So this problem has two tricky parts, right? It had this part that was a little tricky and unusual, and then we also had an unusual z-score that we had to find. Once we have that z-score though, the rest finally will be easy. We will just take that z-score and plug it into our formula. So to get the change in waist circumference we're looking for, we use the formula z sigma plus the mean. Here the z is positive, it's 1.645 times the standard deviation, which is 1.57 inches, plus the mean, which was, be careful here, negative 4.69. Don't forget to put your mean as negative because it is a negative value. All right, and then from there, we're going to go ahead and plug it all in. 1.645 times 1.57 minus 4.69, right? And when we're done, we get a negative 2.11 change if we round to two decimal places. Negative 2.11. That means basically roughly a 2-inch loss on your waist circumference. We correspond to the people that had some of the smallest changes that occurred from the diet and resistance training exercise, right? So in other words, only 5% of the group had waist changes that were this small. Even given that, that's 2 full inches off your waist. That's pretty good results. So even if you were in the worst of the group, the people who got the least effect from it, they still lost pretty good amount of waist circumference. So, and of course, remember, these problems are generally based on real data, and so this is from a real study. And so it looks like, using this diet and resistance training combination for 16 weeks, that's just 4 months, right? The length of a typical college semester, they were able to do a significant amount of decrease in waist circumference. Of course, this was for obese men, and perhaps, for regular people who are not obese, they might not get the same kind of effect. It might be easier for obese people to lose weight initially. So maybe once you're closer to your ideal weight, it would be a little harder, but still interesting results, and it shows the power of diet and exercise.